Okay, so in 5.3, we are adding and subtracting with like denominators. We can do unlike denominators. We're going to pick that up next semester, but today, just like denominators. So step number 1 is to write it as a single fraction. If you have two fractions that you're adding together, actually, or more than two, but just two for us, if you're adding fractions together and the denominators are the same, you can rewrite it. So instead of having two separate fractions, it's one fraction, okay? That's going to be really important to do the next lesson, but so we're going to do it today as well to kind of build onto that. Once we get it written as a single fraction in order, so the numbers I have, 1, 2, 3, 4, the order of those numbers is important and the order of the steps is important. So we're going to add or subtract, factor if we can, and reduce if we can. So after we write it as a single fraction, if you can remember, add, factor, reduce, add, factor, reduce, add, factor, reduce. In that order, that's important, okay? All right, so step 1 is writing it as a single fraction. So that just means the 3x comes over at the bottom, and I take what's in my numerators, 12 minus 3, and bring it over. And then in order, my 3 steps are add, factor, reduce. So I'm looking at my numerator. I do have like terms here, so I can put those together. 12 minus 3 is 9 over 3x. Factor, I cannot factor. There's no signs there, so no exponents there, nothing to factor. And then reduce. That I can do. I can take 3 into itself once and into 9 3 times, leaving me with 3 over 1x or 3 over x. So the 1 would not be necessary, but it certainly can be there, would not be wrong. Question 2. We just bring our 7 over, and then I bring over the numerators. Make sure you bring over the correct sign. So 18xy minus 11xy. And then in order, add, and yes, those can be combined because they are like terms. So 18xy minus 11xy is 7xy over 7. Factor, again, we cannot factor that. There's not a single sign in the expression, so factoring I can't do. And then reduce, yes. 7 will cancel completely with 7, leaving me xy. Questions so far? All right, next one. Bring over that x plus 3. One fraction here, so 5x plus 15. And then in order, add. I cannot add. 5x and 15 are different kinds of terms, so they don't combine. Factor, that I can do. I can take out a 5. 5 from 5x leaves me x. Plus 5 into 15 is 3. And then reduce, yes, x plus 3's. We'll cancel, leaving me just 5. So when you get to that add, factor, reduce, you'll notice that all I can do is add and reduce. Here I factored and reduce. You don't always do all 3 things, okay? I think I have one that you do that with, but All right, so bring my denominator over, and then I bring over x minus 3. So I add, there's nothing to collect that's alike, x minus 3, different terms, x squared minus 9, different terms. Factor, I can factor the denominator. Hopefully, we've done this so many times, you recognize that as a difference of squares. X times x, 3 times 3, plus and minus. We have probably factored, I don't know, upwards of at least 50 to 75 of those. So difference of squares, x and x, 3 and 3, plus and minus. And then reduce, yes. Now, the x plus 3 that's left is on the bottom, which means it needs to stay on the bottom. So I'd have an understood 1 left in my numerator. So hopefully you're seeing some similarities here to what your quiz was just on, because we're doing some very similar things. All right, my x minus 2 comes over, and I bring my numerators, 4x minus 2 minus 3x. And then I add, which I can do, 4x minus 3x is 1x. Minus 2 comes over. Factor, which I cannot do. There's no common factor. There's no powers. And then reduce. So yeah, they're the same thing. So I can cancel, and my numerator is 1. Or my answer is 1, sorry. All right, next one. Bring over the denominator, and then bring over the numerator as 1 fraction. And then I add, cannot add there. I factor, that I can do. My numerator is a difference of squares. X times x, 4 times 4, plus and minus, over x minus 4. So again, difference of squares, even powers, and then our squares. If we don't know our squares, we can use our calculator all the time. And then reduce, yes, x minus 4s.
You wouldn't put a 1 in there.
That's up to you. It can. It doesn't have to be, but if it's there, it's certainly not going to be marked wrong. No. Yes. Okay, my last one. My denominator, x minus 4. And then I bring over my numerators. Oops. And then I'm going to add, factor, reduce. So I write it as my single fraction, and then in order, add, factor, reduce. So the numerator becomes 1x squared plus 2x squared is 3x squared. In the orange, positive 3 minus 13 is minus 10. Minus 8 comes down over x minus 4. Factor, so we're going to check it out here. 3 terms, so I'm going to go to my 2 parentheses. Based on what we're doing, what do you think one of the parentheses is going to say on the top?
X minus 4.
X minus 4. That's real likely because that's what's on the bottom, and we want stuff to cancel. So it's not 100% by any means, but it's a pretty high probability. So when we go to factor that numerator, keep that in mind, okay? So 3x squared, 3x and 1x. Minus at the end is one of each. And then 8, 4 times 2. So I'm going to put the 4 here so it matches, and we're going to see if it actually works. So outers give me negative 12. Inners give me positive 2. And that's negative 10. And boom, that's what we wanted. So use things that are in the question to help you. And then I cancel, reduce, and I'm left with 3x plus 2.